Hello everybody and welcome back. Today's video is going to be about task 3.4, and in this task we're going to be working on a slightly different version of what we've been doing. Today's learning target is I can create the graph of a function given key features. So unlike what we've been doing up until now, instead of giving you a graph and saying, find the key features, we're going to be giving you some key features and saying, please make me a graph that meets these key features. So what I'd like to do before we jump in is I'd like to review what we already know how to find when we have a given graph. So far in this unit, what we've learned is that if we have a graph, we can find where that graph is increasing, decreasing, and constant. We can find the domain and the range. We can find the maximum and the minimum values, and we can find the x and the y-intercepts. What I'd like to do now is go through and kind of do all of this at once using one given graph. So let's start with increasing. So I'm going to use the color green for increasing. A graph is increasing when we look at the graph and it is going uphill as we look from left to right. So on this graph, it looks like there are 1, and then it kind of continues here. So there's one big section of increasing. And then let's see, I've got another section of increasing over here. So we've got 2 sections of the graph, or what we call intervals, where the graph is increasing. This first interval starts from where the x value is -9, and it goes to where the x value is -4. So my first interval would be -9, comma, -4. Now, since this is a closed circle, I would use a bracket on the left. And since this is a connected function, so there's no clear dot there, but since it's connected, we use still a closed bracket on the right. For the next interval, we're going from 5 to 7. So for my next interval, I would put 5, comma 7. And again, these are both closed circles, so I would use brackets for both of those values. Next, let's think about decreasing. So a function is decreasing when we look at the graph and it is going downhill as we go from left to right. So if I'm looking for sections of this graph that are going downhill, we've got a section here, which continues right here. Even though it looks like 2 separate sections, it's still just decreasing the whole time. And we've got a section here that is decreasing. For my intervals, this first section starts from -4 and it goes to the number 1. So I've got -4, comma 1. Since this is closed, since it's nice and connected there, and this is closed, both of those values are going to have brackets. For the second section here, it starts from the 7 and it goes to the 10, which is right here. So my next interval would be 7, comma 10. And again, there's 2 closed circles, so I would use brackets for both. Finally, let's think about the idea of constant. So a function is constant, and I'm going to use the color orange for this. A function is constant if we look at the graph and it looks flat as we go from left to right. So on this graph, we're going to be looking at this one section or this one interval right here from 1 to 5. So this is going to go from 1 to 5. And since there's closed circles at both endpoints, we're going to use brackets for both. Now, as far as domain and range, the domain of our function is going to be along the x-axis. We're going to look for kind of the farthest to the left and the farthest to the right that we go. So on this graph, the farthest that the graph goes to the left would be all the way over here, and the farthest that the graph goes to the right would be all the way over here. So that means that the domain is going to be from -9 to +10, and we're going to use a closed bracket for both because it is closed points at the endpoints. And the range of our function is going to be from bottom to top. So the lowest that this graph goes is down here at the -8. And the highest that this graph goes is up here at the +4. So our range would be -8, +4. And again, because it is closed circles for both, we would have brackets for both. Now, as far as maximum and minimum, your maximum is going to be the highest point on the graph. And the way that we write the maximum is first we find the point, and then we say that there is a max of, and it looks like the highest that this graph goes is 4, at, and then we list the x coordinate. In this case, the x coordinate is -4. So x equals -4. For the minimum, we're looking for the lowest point on the graph. In this case, the lowest point would be this one right here. So we would say that our minimum value is -8. So we would say there is a min of -8 at, and then we list the x value where that occurs. It looks like that's occurring when x is 10 at x equals 10. Last but not least, let's talk x and y-intercepts. So for my x-intercepts, I'm looking for where the graph crosses the x-axis. On this graph, it looks like I have 1, 2, 3, 4 places where the graph crosses the x-axis. And those are going to be the points. It looks like this one's about halfway between -6 and -7. So -6.5, 0. Don't forget that for points, you always use parentheses. And then we've got 0, 0, 6, 0, and 8, 0. Now for our y-intercept, we're going to be looking for where the graph crosses the y-axis. So on this graph, the y-intercept would be where the graph crosses the y-axis. And it looks like that's going to be kind of the same place where we had an x-intercept right here. So that's going to be the point 0, 0. Okay. I wanted to remind you what all of these different terms meant because the new problems we're doing today are going to ask us to draw our own graphs. Here's an example of the kinds of problems you might see today. For problem number 1, it says f of 2 has to equal 3, and the graph is always increasing. Now this means we have 2 pieces of information. The first piece of information that we have here is that f of 2 has to equal 3. Which is telling us a point that we need to plot on the graph. In this case, the point would be 2, 3 because the input is 2 and the output is 3. So before I do anything else, I'm going to go on my graph and I'm going to graph 2, 3. The input is 2 and the output is 3. Now the second piece of information that I have about this graph is that the graph should always be increasing. That means the graph should always be going uphill. So what I need to do now is draw a graph that goes through this point, but is going uphill the whole time. So I'm just going to go ahead and draw a graph that goes through that point and is going uphill. For problem number 2, again, we're given 2 pieces of information. The first piece of information is that f of -3 equals 4. And the second piece of information is that this graph is always decreasing. By telling us that f of -3 equals 4, they're telling us that there's a point we need to plot on our graph, -3, 4. So I'm going to go left 3, up 4, and plot a point there. By telling us that the graph is always decreasing, we need to draw a graph that is always going downhill. So I'm going to draw a graph that goes through that point and is going downhill the whole time. For problem number 3, it tells us, again, two pieces of information. F of 1 is equal to 2, and our graph is always constant. F of 1 is equal to 2 tells us to plot the point 1, 2 on our graph. So I'm going to go where x is 1 and y is 2 and put a point there. Being constant means that the graph should be flat. So I'm going to draw a graph that is flat that goes through that point. So it's going to look like this. Now, in problem number 4, we have a slightly different kind of information. So problem number 4 tells us that the domain, which means if we go from left to right, is -4 and 3. So what I'm going to do is I'm going to add some guidelines on my graph to kind of show those edges where the domain goes from -4 to 3. So that means that the farthest to the left that I'm allowed to go is -4, and the farthest to the right that I'm allowed to go is +3. Now I'm just going to draw a graph that goes from edge to edge. And here's where a lot of students get excited because you have some options. You are allowed to draw a graph that's going uphill, downhill, flat, it doesn't matter. You just want to make sure that you go from edge to edge. So in this case, I'm just going to go like this. I touched this edge, I touched this edge, so I'm done. You could, if you wanted to, draw a graph that goes uphill. You could draw a graph that is flat, and you can kind of get creative there. For problem number 5, it tells us that the range is -5 to 2. Now, in our language, the range means bottom to top. So, in this case, the -5 is the lowest that we can go, and the +2 is the highest that we can go. What we want to do now is, again, just draw a graph that touches both edges. So I'm going to touch both edges and just draw a graph that goes from edge to edge. For problem number 6, we want to draw a graph that has a minimum value of -2, which is one piece of information, and a maximum value, which is 5. Minimum value means the lowest you're allowed to go is -2. So on my graph, I'm going to kind of draw a guideline at the -2. And +5 means that the highest that you're allowed to go, the maximum means that that's the highest you're allowed to go, is +5. Now I'm just going to draw a graph that makes sure to touch both edges. So the lowest I'm allowed to go is here, highest I'm allowed to go is here. And again, you could go uphill, you could go downhill, you have any options you want, it doesn't matter. For problem number 7, it says the minimum value is -3. So minimum means the lowest you're allowed to go is -3. And the maximum value means that the highest that you're allowed to go is +1. And we're just going to connect so that we touch both edges. So I've got one here, I've got one here, and we're going to connect the dots. Now for problem number 8, again, it's a slightly different type of information. So problem number 8 is telling us that the x-intercept, which is where we cross the x-axis, needs to be 4, 0. So I'm going to graph the point 4, 0, and then I just need to draw a graph that goes through that point. So I'm just going to make a graph that goes like this. You could also draw a graph that goes uphill. It doesn't really matter. For problem number 9, it says that the maximum value is 4. So that means the highest that this graph can go is 4. So I'm going to go ahead and draw a guideline at 4. It says that the minimum value is -1. So that means that the lowest this graph can go is -1. And the x-intercept is 2. So where the graph crosses the x-axis is at 2. Now I'm just going to draw a graph that touches the bottom, it touches the top, and it goes through that point. So let's see here. I'm going to go from here, and I'm going to touch up to here. There we go. And we're done. Thank you guys so much for watching, and I will see you soon for some practice.